Yep. In your second half of the lecture, Tim must have started with chapter 5, sequence, series, limits, and all those things. How much have you covered in the lecture? Okay, so in today's prac, I plan to go through an example of bisection method, which I think in the lectures a bit is covered. And then in your assignment, there is one question where you need to code bisection problem in Mathematica. Okay, okay, let me go through. Okay, so the plan for today's tut is to help assignment 2. Assignment 2 is due 2 weeks afterwards. So you got a lot of time to go through the questions. But let me help you with the bisection example, okay? Basically, can anyone tell me what is the theory behind bisection? Okay. If you attended the lectures. Yeah, binary searching kind of things. So why would you use the bisection method? Yeah, divide the range. Okay. Yeah, some of you are on track. What are the advantages and disadvantages of that method? Yeah, it is robust. It is exact. Why? Why is it exact? Inexact. Okay. What's the advantage of it? Are you sure it's quick? yeah, gets us closer to accuracy, but there is very big advantage compared to other methods like Newton method. All right, let me give a little bit background of the bisection method before we move on to the coding part. So the plan I have is I would be using, like after explaining the theory, I would be using an example which Dr. Sam Hamilton's tutorial, which is already available in YouTube. But I have coded it here for your convenience. So instead of me doing all the codings, I would like you guys to code it after I give you the algorithm to it. Okay. I will upload all the codings on GitHub. Okay, after maybe like today or tomorrow. Okay. First of all, let me share the notebook. Okay, in the notebook, I have just given two examples where I would like you guys to code. Okay, I'll give you guidance on it. Let me share it. Okay. Please make sure that this is a walk-in notebook. So look for updates on GitHub. All right, little bit background about bisection method. Okay, let me illustrate this with an example like function where I don't know the exact function, but let's say you have this function. Where you have this line, this curve here, which is crossing the x-axis at one point. So the aim of a bisection method, it's a root finding method where we find where when fx is real, continuous, and defined in an interval, defined on, let's say, interval AB and continuous on the interval, we know that the two values with opposite signs. So that's the condition. And the aim is to find a root that is solved for fx equals 0. Okay, get an approximate solution. That's the aim of bisection. Okay, now in order to apply the bisection method, I've already said you need a function which is defined on the interval AB, and at the endpoints f of A and f of B have opposite signs. If they have opposite signs at the end, by the intermediate value theorem, f must have at least one root in the interval AB. So this method guarantees a solution. It guarantees convergence. So that's one advantage of the method. Then the idea is to repeatedly divide the interval into half and select the subintervals in which the function changes sign. Okay, this is an illustration where it started with A1 and B1 here. Okay, and in between at f of A1, this is negative, and f of B1 is positive. So that condition is met. The function is continuous in the interval A1, B1. And then what happens is you take the average of the endpoints A1, B1, and then let it be C, and then compute f of C. Okay, if in this case, check the sign of f of C. Okay, if f of C is positive, it's close to the interval, it's close to B1. So in the next iteration, you would say, you would say that's B1 is C. So you move close to the, now you take this interval. Okay, maybe this is B2. Okay, and then continuously divide it until you get a very until you get close and close to the solution, which is marked in the red line. Okay, the bisection method is okay. Now, if you want to implement this into a programming language, you need the input function, the interval, f of A, f of B, and then each iteration perform these steps. This is what I just explained. Compute the midpoint of the interval, compute f of C, check the conditions for convergence. This can be met if the absolute value of C minus A is sufficiently small. Usually you give a tolerance here. Or the absolute value of f of C is sufficiently small. If that's satisfied, return C. Otherwise, you check the sign of f of C. This is repeatedly dividing the interval. Replace either the point A, f of A with C, f of C, or B, f of B with C, f of C. Okay. Then these are the this is how the algorithm would be implemented. So that's your input. Check the conditions and produce the output. Okay. Then for n equals 1, this is the number of steps that you are required, which you need to give because otherwise it may not work. Okay, while n is the less than or equal to max, you do these steps. Okay. Okay, that's how you implement this in the program. Okay, in the program, in any program which you are familiar with. Okay, now that's the number of steps required is given by this is P of A. Let's say is less than or equal to log 2 the E0 divided by epsilon, which is in this case that's the E0. That's E. Okay. So the convergence is linear, which makes it slow compared to the other algorithms like Newton method. But this really have the advantage because the convergence is guaranteed by the intermediate value theorem. Okay. Just to give hand calculated example for the first iteration, let's look at this curve. Fx equals x cubed minus x minus 2. There is a solution between 1 and 2. Let's say A is 1, B is 2. And then you would compute, first compute, check whether they have different sign, and then compute C1, which is half of the original interval, and then compute f of C1, which is negative in this case. So C1 is somewhere here, which is negative. Then you move on to this interval, okay? 1.5 to 2, okay? And then repeatedly do those steps until the criteria, that is the absolute distance between of the interval is bigger than a tolerance level given. Okay. So that's how the algorithm is implemented. Okay, this is an approximate method to the solution. It's not an exact, so but you can get quite close to the solution. All right. Now the example that I'd like to go through is already explained in a YouTube, very clearly in the YouTube video of Dr. Sam Hambleton. Let me. Okay, let me share the screen. Okay, this is the example that he explained very step by step. The function is sine x minus 3 plus x cubed minus x to the power 4 plus 15. Okay, and then I implement bisection method on the interval minus 1, 3, which I have given in the notebook. So the way this works is, let's look at. Okay. First of all, plot this function to check whether, so instead of me doing all the work, I'd like you guys to follow through these comments and then code this, okay? First, plot this line, this function to check where the interval is. Okay. It looks like there are two roots in that interval. One is between -1 and 1. The other one is 1 and 3. So you could pick an interval -1 and 1 and start the code in here. Okay, so the first step here is, let me show you the comments. If you have time, please look at the video. First, plot this the function to check whether where the interval is, and can you guys code these steps? By the way, these names, the function positive or zero is the name which I gave. You can change the name to whatever name that you would like. Let me know if you have any question, okay, with this coding. The stars, the bracket with stars are comments. Okay, I have explained what's step by step what's happening. Well, this is a step-by-step process. You can ideally combine all these steps in like a very simple coding. Try it by yourself. Okay. Is there any question? What's the solution that you get if you have done the coding? It's the approximate solution. Oops, something went wrong. Okay, let me start this over. Hmm. I think I messed up with the brackets. So let me. So that's positive. One, two, three, 1, 2, 3. Yeah. 3, 3, 4. Yeah. Did anyone get this part run smoothly? I'm not sure why I'm getting there. Maybe I am the incorrect brackets parenthesis system. Two. One, two, 1, 2. Okay, the idea behind this example is for you guys to learn how to code bisection method. Okay, if you can do this in another way, that's okay. Okay, if this works properly for you, can you guys do this example, the second example? Can I ask, what's the approximate solution that you got? Did anyone get any approximate solution? You can have your own method of coding. Like, is there any question regarding this or the theory behind, the idea behind bisection method? If not, it's almost time, so I'll have to stop for today and see you next week. Okay. Please do refer to GitHub for an update on this example and coding.